Hello, everyone. I hope you are doing fine over there on the other side of the world. My name is Eduardo Ibar Placer. I am an astronomer, a professor at the University of Valparaíso of Chile. And today, I'm going to talk about astronomy, in particular about the past, the present, and future prospects for Chile, always from the point of view of a Chilean astronomer. Before starting with the main topic of this talk, I wonder about what you know about Chile. Probably many of you have heard about Chile because of its nice wine, which you might find it there in Dubai as well. Or maybe recognize Chile because of some famous football players, some of which have even played at the United Arab Emirates. Well, beyond this, in the scientific world, Chile is known as the best place in the world for performing astronomical observations. For thousands of years, the clear skies have been a fundamental part of the different cultures that have lived in our planet. In northern Chile, the privileged clear skies have been a fundamental part for the comprehension of the surrounding universe. The sky works as a clock, which tells the best time for sowing and harvesting, a knowledge which was essential for optimizing food production in early cultures. It was not until 1843 when John Mowat, an eccentric Scottishman, a watchmaker, installed the first telescope with modern characteristics at the city of Valparaíso in Chile. During the 19th century, measuring the time was key to calibrate chronometers needed to navigate over the sea. Valparaíso, as a port city, was one of the last points before embarking to the big adventure of crossing the Pacific Ocean. John Mowat used a time ball, an instrument to communicate the midday to all ships at the bay, so all sailing ships were able to calibrate their chronometers before continuing their trips. At that time, there was a tight connection between astronomy and transportation over the globe. I would like to highlight two other astronomical projects which followed John Mowat's one. On one hand, the North American US expedition led by the Lieutenant James Gillis, which ended in the inauguration in 1852 of the National Astronomical Observatory in Santiago de Chile, followed by the later arrival of the Lick Observatory from the University of California at the beginning of the 20th century. The installation of this larger telescope, dedicated to astronomical research from the southern hemisphere, facilitated the exploration of the stars over a large part of the Milky Way, which was not well seen from the northern hemisphere. Chile has some unique properties for exploring the universe. At the left-hand side, you can see a map of Chile, this long and narrow South American country, which covers a wide range of different climates. Northern Chile is particularly important for mining industry, which is a major source of economic income for Chile. At the figure on top, you can see the main geographic features. At the left, the Pacific Ocean, and to the right, the Andes Mountains. This peculiar geography makes northern Chile one of the places in the world with the largest number of clear nights per year. Specifically, the cold ocean and the dry weather don't allow the formation of big clouds, while at the same time, the high altitude of the mountains minimizes the effects produced by the Earth's atmosphere. Today, Chile hosts a large number of astronomical observatories. Here, I highlight some of the largest ones, such as Gemini South, which has a brother in Hawaii with similar capabilities. Cerro Tololo, as one of the first large US laboratories installed in Chile. We also host the Las Campanas Observatory of the Carnegie Institutions for Science, presenting the two Magellan telescopes of 6.5-meter diameter each. Some of the largest ones are at Cerro Paranal, administered by the European Southern Observatory, containing four 8.2-meter diameter mirrors, which can act as a single telescope using interferometry. But Chile doesn't only do optical or near-infrared astronomy. We also observe at millimeter and submillimeter wavelengths. For example, hosting the ALMA Observatory at 5,000 meters above the sea level, composed by 66 antennas capable to observe at frequencies between 35 and 950 gigahertz. The opportunity to have access to all of these state-of-the-art facilities have generated a great impact on the local astronomical community. Almost 300 professional astronomers are today working in 24 academic institutions, and this community is still growing and preparing to the arrival of newer and more challenging projects. One of these institutions is the University of Valparaíso, which is third in ranking when talking about the number of professional astrophysicists actively working today. We provide undergraduate and postgraduate programs to do research in all of the main astrophysical topics. Please note that applications are now open, so please go to our website if you want more information. Our Multicultural Institute includes strong national and international collaborations, with also a tight commitment to outreach activities for the local community. We are also developing a remotely controlled 61-centimeter telescope for educational and outreach purposes. The University of Valparaíso, together with the rest of the Chilean institutions, are preparing for the upcoming new wave of telescopes to arrive within the next decade. For example, the upcoming observations to be taken by the Vera Rubin Observatory, a telescope with a primary mirror of 8.4 meter diameter and a 3.2 gigapixel camera, will observe the entire sky every 3 nights, gathering something like 20 terabytes of data per night, which will be repeated over 10 years to reach something like 60 petabytes of data. This is a perfect laboratory, not only for identifying new objects in the sky, but also to develop new tools for big data exploitation. Here, very interesting transdisciplinary research can occur. For example, the one recently named astroinformatics. On the other hand, the arrival of the gigantic telescope, like the Giant Magellan Telescope, located at the Las Campanas Observatory, will revolutionize our view of the universe. It will consist of 7 mirrors of 8.4 meters each, reaching an effective diameter of 24.5 meters. It is expected to start observations within the next couple of years and will tackle some of the most fundamental questions in astronomy. Are we alone in the universe? How did galaxies form? What is the fate of the universe? Another incredible project is the extremely large telescope located at Cerro Armazones and led by the European Southern Observatory. This gigantic telescope will have an effective diameter of 39 meters, putting a tremendous challenge for engineers. This cutting-edge technology is created for human desire to understand if there are other planets like the Earth where life could exist, while also for detecting the faintest and the most distant galaxies ever seen. This astronomical revolution is also accompanied by the Cherenkov Telescope Array. This telescope mixes high-energy physics and astronomy. This telescope has a second site at La Palma, and it is composed by several different telescopes with different sizes that can see the light from the universe coming from 20 giga-electron volts up to 300 tera-electron volts. This will provide a unique view to the highest energy processes of the universe. Within the next decade, all of these projects, apart from several other of smaller size, will imply a nearly 7,000 million US dollars of astronomical investment in Chile. This fantastic scientific and technological industry, however, has a tremendous threat: light pollution. But based on the definition given by the Ministry of Environment of the Government of Chile, light pollution is defined as the alteration of the natural darkness of the night, caused by wasted, unnecessary, or inadequate light generated by outdoor lighting, which generates impacts on the health and life of living beings. This contamination does not only affect astronomy, but it has also been reported to be the cause for an alteration of natural cycles for living creatures, including animals and humans, insects, animals, and humans. As an example, on the left-hand side, you can see the Orion's constellation as seen from an astronomical observatory, while on the other right-hand side, it is the same patch of the sky, but taken from a city. The difference is remarkable. On one hand, we can see plenty of stars and details, while on the other, we can only see the brightest stars. Light pollution causes the impossibility to have contrast in images. Therefore, the scientific desire for building the largest telescopes ever built by humanity could be jeopardized by the fast-growing light pollution. Last September, the Forbes magazine highlighted that during the last 25 years, global light pollution has increased by up to a factor of 400%. This is a tremendous waste of energy, which is equivalent to a tremendous waste of money. I would like to send a message to the main industries involved and the local government for finding sustainable approaches, which must follow strong regulations for a better use of energy, especially in regions surrounding astronomical observatories. Here's an emblematic example, what should not be done. A very nicely illuminated highway right next to the main astronomical observatories in Chile, connecting two cities like Vallenar and La Serena. On 2014, there was no highway, but in 2016, it's clearly seen from space the appearance of this light dots you can see in the image, which affected significantly the observations at the Las Campanas Observatory, increasing even by a factor of 2 the background levels of light pollution at that observatory. In this example, it seems like everyone forgot that Chile is the astronomical capital of the world. On the other hand, the new proliferation of LED lights in cities and mining industries aggravate the situation, because this new form of light emits strongly in the blue side of the spectrum. This blue light easily disperses in the atmosphere, producing contamination which can be detected even beyond 150 kilometers from the point of emission. This kind of pollution is extremely aggressive. This is a problem which involves several aspects in Chile, including energy efficiency, environmental protection, public health, and scientific interests. For example, in the last year, in the US, Philadelphia, an unexpected event resulted in the death of over 1,000 birds. There was a storm, and a flock of birds got unfortunately disoriented by city lights, smashing into big buildings. This is just one case, but there are several others reports of massive deaths of migrating birds as they get confused by artificial light at night. Other recent studies point towards that light pollution being related to the generation of breast cancer. Published by Lampard et al. 2021, a study that analyzed breast and prostate cancer and its relation to light pollution as seen from space, found a significant increment of breast cancer within regions of Slovakia that are over-illuminated. Although it is still early to conclude a direct relationship, these scientific studies are telling us a warning for humankind, and we should not hide the problem under the rug. To finalize, I hope this talk helps you to recognize Chile as a major astronomical power, has today the concerning problem about the light pollution. Light pollution is a global issue, as the same as global warming. We look at the universe as a mechanism for scientific and technological development, while also for human appreciation. If you are interested in my talk and want to discuss potential ideas for developments in Chile, I leave here my email so you can contact me directly. Finally, I would like to thank the Spatial Australis Foundation for the opportunity to be here today. Thank you very much for your attention.